So in this last part, I would like to show you what would be the most efficient process to structure actually your blend file and then to export your complete design over into Fusion. Because essentially in Fusion we will rebuild this design, but we want to be able to just quickly rebuild this object with the least amount of steps and labor work. And in addition, let's say at one point I change a part in Blender, I would like to be able to quickly update that also in Fusion. So first, let's take a look at what, for example, we would have to bring over to Fusion. So this is kind of like an end result of the mirror command with the bend, the subsurface, and then the different trim commands or Boolean commands. So for example, these Boolean commands, we will completely rebuild from scratch in Fusion. So this type of a mesh, this end result, we do not want to bring over. Actually, you could turn off all these eyes till the subsurface. So the subsurface we don't need as well. But then you actually would get the raw object, but you don't really want to go to all these different parts and then turn all the stuff off and bring it over. But you remember that we are actually using cloned data. So if I go to layer 1, here is, for example, my sculpted start, and here is, for example, my sculpted master. See, I renamed it Toothbrush Sculpted Final Master. And this is the same geometry that drives the plastic part as well as what, for example, should be the overmolded part, because they all, again, share the same geometry. So when I want to get this geometry over, I don't really have to select this object and then turn all these modifiers off. I simply select like a clean master object, which I have as a backup, and that one I will export. Okay, so let's do this. With this object selected, I want to turn off subsurface. That one I don't need. And then we go to export, wavefront. And for example, selection only, Z up, maybe X forward. Let's go to the desktop, and we could, for example, call it Toothbrush. Okay, export. Let's go to Fusion. Before we continue, you want to go to Preferences, Design, or General, and then switch to Default Modeling Orientation Z up. Some programs use Y, some programs use Z. I always like X and Y to be on the ground and Z always up. So that's the reason why I selected, apply OK. And then maybe make a new design, and then the Z-axis for vertical will be accepted. Okay, so this is now the Fusion interface. Quick intro, we can rotate around. Up here, for example, we have some modeling commands to extrude, revolve, sweep, make a box or so. Here we have modify, combine. That's, for example, the like the Boolean operations. We have a split body. We can move an object, and yada yada yada. Okay, so I would like to bring over the Blender model, which we exported as wavefront OBJ, and the T-spline module in Fusion, as you can see in this image, gives you the same subdivision surface sculpted technology we also can use in Blender. So we can click on Create Form, and then we go to Insert, Insert Mesh, and here's the toothbrush. Okay, because I set up Blender to meters, so metric, you want to use the scale meter, and click OK. And there's actually no the toothbrush. So you see this actually looks the same way like in Blender, because essentially it is exactly the same geometry. But this currently we would like to smooth out, so we can click this object and go to Modify, Convert, and then sometimes when this is the T-spline body selected, you can click it and click here on Select Mesh Body. So the raw polygon mesh, click this one, say New Body, okay. And there is now actually our subdivision surface body. This toothbrush, this polygon mesh, we can click and delete. And then we can click Finish Form. And let's take a look when we zoom in. You will see what is different compared to Blender. There's no subdivision level 1, 2, 3, or 4. So this is one of the big differences between how subdivision works in Blender or Modo or Maya compared to how subdivision works in with T-splines in Fusion. Fusion gives you perfect smooth results. To, for example, go back to edit it, we can right click onto this feature, say edit. Let's take a look. We'll just show you how this works. For example, we can select this point, click on edit form. For example, move this one up, and you see we can actually, similar to in Blender, modify this stuff. Because essentially this is now exactly the same sculpting module or process. There are certain differences between what T-splines can only do and what Blender offers you. In addition, I will go into that in a later video. And for example, we could also maybe show the display mode. So with this object selected, I could shade it flat, so basically no subdivision at all. I could show this, for example, with the smooth surface and the polygon cage, or for example, we project the cage also onto the smooth surface. So you see, it is exactly the same. Okay, so this was step 1. Let's go back to Blender. I keep this one on again. So let's, in this case now, bring over our trim surface parts. So I will select all those, and let me see if I have anywhere something specific. So here I have a bevel command. So I would like the subdivision surface to be turned off. Yeah, okay. So in this case here, because this one uses a bevel command, I would like to export all at the same time. So I quickly turn for all those the subdivision surface off. And then I can press spacebar, export OBJ, and then again select it only, apply modifier. Notice apply modifier will, where I have a bevel command here in Blender, will create that geometry for me inside Fusion. So let's go back to Fusion. Now I will create another form. Go to Insert. There's my toothbrush mesh, meters, okay. And then I will go to convert, select these objects, okay. And there you can see I have my split surfaces. So now with this polygon mesh I can delete and, for example, exit my view. Okay, perfect. So let's see what we have. Let's maybe work with the tip. So here, this area, for example, we would like to completely remove. So I could go to split body, this body, I split with this surface, click OK. And you see in bodies now I have an additional body. And this one, right mouse button click, I say remove. If you delete, you completely delete the object. I just would like to remove it outside the timeline. And you see here in the timeline, it adds now a remove command. And if I go back in the timeline, it's still there. If you delete, it is really gone. And for example, the same would be for this part, since I don't really need it anymore, so I clean up my design a little bit. Okay, so this object I would like to split via, oops, wrong command, split body via this face. Okay. And for example, in this one, we can remove, and then one more split body, this one split with this. So you see, actually, this is an advantage of Fusion here, because it has a dedicated split command. Currently, Blender only can trim something off. So if I hide maybe this one or this one, you can see all the different parts. It's actually pretty awesome. And if I zoom in, you also see perfectly smooth. So like in Blender, your best friend also here is save. Actually, we don't have to save regularly because Fusion saves on an automatic basis, but sometimes you can have certain software bugs or issues. So currently you see I have this yellow surface here and I don't see it inside my body lister. So I will save this design. This is, for example, now the save dialog. So you save online in project. So I go to my project, Wayne State Industrial Design. Otherwise you could create a new project with this button. Inside the project you could create a new folder with this button here, and let's say I call this one Toothbrush. Oops, there, proper spelling. Save, and Fusion now will save this file, cache it locally, but upload it online. The great thing is, whenever you go to a different computer and log into Fusion, you have your design online there. And to open it, you could, for example, go to the dashboard and go to Wayne State, and there is my toothbrush model, and then just double click it and it will open it. And let's see if my workaround worked. And there it is. There's no the stitched part. So that was the object that wasn't visible. And knowing that that bug, I knew that I just needed to save the file. And then when Fusion refreshes the cat data, it will show it up. Okay, so let's see what would be the next step we could work on. Yeah, maybe this cavity here that's open, I would like to add the smaller surface. And so let's go back to Blender, and this is actually this part here. As you can see, That's the geometry which we shrink by using a displacement modifier in Blender, and then we add the trim stuff. Now, because this is actually just one object and it only has two trim tools, I simply here in this case quickly turn this off, turn also this off, spacebar, export it, and I can turn this one back on for Blender. And let's go to Fusion. And now where do I insert it? Do I insert it at the beginning with these bodies? Do I insert it later? That's really up to you how you want to structure it. We could create a new T-spline model here, and functionality wise might not really be much of a difference. It's more maybe organizational or structural difference. I will just create a new object and then insert. Here's my mesh meter and convert. Okay, and then let's delete this one, finish form. Okay, so maybe everything else here I would like to hide for the moment, because now we'll go split body and split this body with this surface. Okay, and then there's something I would like to show you now. Let's see if this all works perfectly. And ooh, this part actually intersects a little bit. So in Blender, this geometry was actually not smooth, but linear. So we have to actually crease this very smooth surface so we could get the same shape. I could also actually have modeled in Blender this one with the sub-D modifier nice and smooth, but that would have added more geometry points, made it maybe slower. So I work with more a linear mesh. And to turn something that is smooth in T-spline to be linear, we can use the Crease command. So Crease edge. And now I have to obviously be careful with object I click on, but here you see there are these edges I can click onto. You can also change the visual style to see hidden edges or only edges also with this command. And let's click OK, finish form. And then you see that actually it indeed did not change and update the split correctly. So let's maybe go forward and backwards. Oh, interesting. This actually should not have happened. Not a big deal. Right click, edit feature, and we say it actually forgot what splitting tool. So the splitting tool is actually this body here. Okay, and there it's updated. Perfect. So now actually in the timeline I can select this one and also say remove. Okay, and now you see that this one perfectly intersects into or sinks actually into this design. It doesn't stick out. Now I would like to fuse these two different objects together. So for this we can use the combine command, and then we say A plus B join, so union, difference, intersect. Okay, and there's actually my part now. And you see inside the body lister, it's only one part now. Before those were two objects. So this combine actually combines the two objects together and hides actually what's selected blue, because essentially you might just only want to have this as an end result, so one object. Okay, let's change this back to this layer. And maybe let's take a look at the other part. Oh, what's this one actually? That's that overmolded part, so we can delete it. This maybe makes sense. We go to here, and then there in the timeline say that one remove. Okay. Yeah, perfect. Okay, so let's work on this one. We would like to core this one out and also cut the sides out. We pretty much have to do the same steps we did in Blender. So let's see, where is my design detail? So here, bevels for the moment I turn off. So I only have my array and then the bend command. So for example, the bend command, that's something that's currently missing in Fusion. So this type of a detail would be very labor intensive and difficult to make in Fusion. But as you can see, getting the same model in Fusion and getting the data over is insanely easy. Which maybe at this point you start realizing that Blender is just not a program for its own, it's just a toolbox. And Fusion is another part inside my toolbox, and these two programs or tools perfectly complement each other, because everything I do in Blender or Alias I can feed into Fusion and then there simply finish it. So this part we would like to get over and export wavefront OBJ and export it. Let's go to Fusion there, and I will not actually create a T-spline. I will create actually a base feature. With a base feature I can insert mesh as well, but I can say take this mesh and create NURB surfaces based on the flat sides of this mesh. So mesh to B-wrap. Okay, and this one we can remove. And now here I have a perfect set of NURBS cubes. Finish base feature. Okay. Maybe I would like to fill it, so bevel these edges. Then here I would have to go ahead and select all these edges. It's a little bit tedious, so I will only do it with those few here. The rest you can do yourself. And then we can pull this arrow a little bit, or for example type in 0.5. Ooh, that's too much. 0.25, 0.3, 0.4, yeah, 0.25. Okay, press enter. Good. So you see now we inserted a new base feature, so the geometry, and then the end result there we can select these edges and give them a fillet. You see, this is actually similar to the edge weight in Blender when we tell the bevel command not to bevel the complete object but certain edges, and also here when you hold on a Mac the Apple key, or I think on Windows the control key, then we can add or even remove edges. But there's no weight, so 1 to 0 is just bevel it or do not bevel it. Okay. So this object now we can use to cut out. So combine, U, but not join, this time cut. And I also do not want to keep my tool, So all those cut tools will be discarded when I click OK. And there you see it is all gone. Perfect. Now actually I do not want the edge fillet at this point. Later I would like to do the edge fillet maybe in a separate step. Then in the timeline I could, for example, delete it. And then you see now everything in design-wise got updated, just minus all those edge fillets. Pretty awesome actually. Okay, good. So we need to add the volume and then we have to core this one out. So let's go to Blender. Let's see where the core part is. This is actually, yeah, that's for the volume. So this one we can turn off. Export out, okay. And then let's go back to Fusion. Yeah, at this point I will create a new object, insert here. Okay, and you see maybe it's not a bad idea to break this up into different imports, because then inside the design timeline you can see when you and how you use them. Specifically when at one point you want to swap out this mesh, you can just simply go to the correct T-spline object and swap out the mesh. Let's delete this. Okay. And we set add the volume to it. So question now is, how can we actually add the volume to it? You see, but if I add the volume to it, then the rest will be cut out. So can, for example, say menu, join. Okay. But then I have this stuff added to it. So let's see, where do I have a soft delete where I stop the trimming? Not stop the trimming, where I remove the split surface. There. Okay, so this object I might need. So here in the timeline, I delete actually this feature. Zip. So I tell the software, hey, please don't delete the software. And then I go back in the timeline. And now here I can do another split body and say you split with hue again. Okay. Split issue. I see. Okay. Let's see. So what could be an opposite way? Well, maybe we could split this part first. So split you with you. Okay, so you see that actually will work. So you see I have actually the small part there. So let's see, you and you together, will that work? Yeah, that worked. Oh, actually, this last command there I can delete. I just did a double. And there you see, I have the same result. Now at this point, I think I'm pretty good that I can now finally really say goodbye to this mesh. I don't need it anymore. Okay. And now we have to core this part out. So let's go to Blender. And where is the core part? That's this one. Yeah, so we actually brought this one over. but then we used it actually for the back part to cut the piece out. So this is actually now where the timeline can come in very handy, because I can also move actually the commands or groups forward and backwards. Ideally, preferably what I add to here, I think the tool I add to this part, I would rather first to cut out this other part, keep the tool, and then I can actually trim it and then join it to this part. So yeah, let's do that actually. So where is this feature being worked on? So when I click on this object in the timeline, it shows me when and where, for example, it's being worked on. So let's go to there, and then we have this object here. Okay, we go one step back and one step back. Okay, so there we have this command, and these two objects here, yeah, they influence this end result. So joining this to this part, I will click and drag, or try to drag it over, maybe move the timeline to there at the end, and then drag everything over. Yeah, this worked faster. Zip. Okay, so we still have actually this one, how could I say that, joined to it. But if I now go back in the timeline, you see this is my end result. But I can go back, and then I still have this part, and let me see, where is the other one? There. So there, for example, now out of body 8, I can cut this trimmed object out. So let's do this. So you, not join, cut, but keep please the tool. Cut this out. Okay. So you see now how it actually it carved it out. And I told it to keep the tool, because this tool I need for the next command to join it actually to this part. And there now we have the two parts that perfectly fit on each other. So it was actually a good exercise and demonstration for the timeline, how useful it is when you want to move parts forward and backwards. Okay, so you see this is actually pretty easy. The logic behind here is pretty much the same how, for example, the modifiers work inside Blender. The design structure in Blender is similar to the design structure in Alias, so all these modifiers are on a per object basis. And in Fusion, you will see you don't really have a per object basis, but we have more a timeline that shows you all the different design steps you took to create and come to this object. And the nice thing about the timeline is while it's linear, so start to end, but it gives you a nice flow, and you can also rearrange visually the steps. I think that's sometimes a little bit easier on your eyes, or to imagine what's going on. Obviously, when you have a very dense design, also the timeline can be a little bit difficult to read. The last piece maybe I would like to bring over is, let's say, the text. Text is missing. Then we have to bring over the bristles. So let's go to Blender, and where's our text? let's see, there's the text. What do we have here? This is SVG. We can bring SVG over. We can also, for example, bring the cleaned up geometry over. I will actually go with this process. So how do we do this the best way? Yeah. Yes. So I will make myself a copy. Shift D, escape, and maybe move it onto a different layer, because I will remove this. And for T-splines, I will remove all these caps. So this is all open now. Okay, good. So the main reason for this is, let's export this. Let's go back to Fusion. Let's go create and insert mesh there, meters, and then let's convert it. And let's delete this. And as you can see, everything starts to look kind of funky. That's because we were smoothing everything. So we have to know crease a lot. So for example, from E, Z, T, A, and L, we more or less can crease everything there. Now we have those straight edges back and those linear letters, and then here there are actually 2, 3 edges. We have to crease, and we're good. What about this one? Maybe and there. So yeah, maybe here and there. Okay. So why did I actually bring this over into TS and not go via a base feature and then edit the flat geometry? The thing is then my tier would be very faceted, and I want this to be round. So in this case, because I had a letter extrusion, I can easily crease all these few simple edges, and I have straight letters back, and then keep the rest with the D, for example, nice and round. Okay, so there we have this part now, and we have to do a little bit of patchwork now. So for example, we could go ahead and say, let's see, what would be the best way? Yeah, maybe a little bit intro into further how to work with T-splines. We can go with patch, and patch means we fill actually a face. And I do the same for the bottom. By the way, like what I'm doing here is right mouse button and then pull it up. That's kind of like the gesture system. And then when you do this, actually it repeats the same command. So when you click and hold, you see you get this command here. So it's kind of like a gesture. So every time when I go over it, it understands I was using the repeat command. Okay, so all these, I have now, for example, the top face and the sides and the bottom face. I have to stitch all these parts together. So I use modify and stitch. And what stitch does is, well, kind of like sewing, it sews all the stuff together. Zip. And, oh, that's not what I want. So undo. This one hide for the moment, and this one hide. Let's take a look from the bottom. There are some, looks like I missed one or two. No, I did not. It's all finished. Okay, good. So again, stitch, cancel, stitch all this stuff together. Perfect. And now I have these two faces left because I need these two faces to actually split this body. So I could go split body U via this surface here, extend, okay. One more time, the A splitting via this triangular shape, extend, okay, good. Then this and this I can remove. And for example, this core and this part I can remove. Okay, so you see now I recreated my myself, my safe, watertight three-dimensional volume letters. Okay. So what was this one actually useful for? So first let's go to the overmold part. So this overmold part here, there I would like to go to combine. So model, combine, and say this object and selection 1, 2, 3, 4, 5, 6. Cut, but please keep my letters. And hold on, where's that body? Ah, body 47, there. Okay. So we have this issue here. Interesting. So you see this. Oh wait, there it is. Wah, wah, shouldn't have spoken so fast. There, okay, perfect. So these parts are still there. Good, that's actually what I thought we will get. Okay, so this is, for example, now what would be the overmolded part. And let's hide all this and show the rest, because now we have to figure out how, for example, we add this to this part. So we could, for example, now go to combine and say U, join with E, D, N, T, A, and L. Okay. Did I say keep tool? Hold on, edit feature. Oh yeah, keep tools now. There. Perfect. And there's the rest. But now you see the letters stick out a little bit. So I would like these letters now to be nicely flush. So at this point I will go back to Blender. Let's go to this layer, or was it on this layer? Oh, on this layer here. No? Ah, this layer, there. No. Hold on, sorry. There. That's actually the final letter trim. Okay, so this object I have to bring over, excluding the subsurface. And then a new T-spline object, insert the mesh. There, okay, meters. There, convert, okay, delete this part, finish form. So, but maybe I want this to be before. I'm a little bit no, this should actually be bigger than the rest. So yeah, okay, so split body, you split via this big thing around it, which should be body 49. Okay, body 49, go away. And I think then this should be only those leftover pieces. Yeah, perfect. Good. And let's say remove. Great. So because the thing to cut the letters was the same shape as the toothbrush, just a tiny bit bigger. It didn't really split anything with my toothbrush. It just split the rest of the letters. So if I, for example, hide everything here, there you see now the end result, this part nicely. And for example, the overmold part and then the tip. Okay. So maybe the last thing to work on is actually the bristles. And as simple as they were in Blender, that process we used so far could easily bring Fusion down to its knees. So why? Well, the thing is, Fusion is, in terms of precision, completely outperforming Blender. So it's more precise. It's actually perfectly precise. The problem, however, is that math precision also comes at the expense of calculation performance. Blender, on the other side, is not very precise, but it is very, very fast. So this type of geometry we created here with all these lines, that would bring T-spline to its knees. So that's not something we want to use, but there's always a workaround and an easy simplification. So this is, for example, here my masterpiece I started working on, and I will generate now a T-spline appropriate geometry. So I will Shift D and just make a copy, not a clone, and put this maybe onto this layer. And then let's select this part. This is 3.51. Shift S, cursor to selected, go to the cylinder. I will make a copy, Shift D, escape. Let's go back to the cylinder here, and then Shift S, edit mode, Shift S, cursor to selected. We have, yes, plane. And we make a huge plane, scale it down. There. And then, for example, we have to rotate it from the side, our 3.51. We are in local space, so now we can press E and extrude a cube out. There. Perfect. So why did I do this? Well, the bristles are honestly just not really important for the design. Plus, what I have here in terms of cylinders is just a simplification of bristles. So we could easily create a cube-like structure, and then we simply crease all these edges, and then, for example, say, hey, smooth those cubes into not perfectly looking cylinders, but something that looks roundish and everybody will read as bristles. So this is actually sufficient for our task. So this stuff I have to bring over to Blender. So I will go Object, Apply, Make Duplicates Real. Sorry, I said bring over to Blender. I meant obviously to Fusion. So make real. There are now all our real objects. Shift H to hide all the rest. H hide this. And there are all these individual objects now. So I can select them. Oh, that was not good actually. How did this happen? Hold on 1 second. Why do I have these others there? So hold on 1 second. Let me undo a few steps. Oh, this one is still there. So X and delete. Let's delete it. Okay, good. So now we have this back. Yeah, okay. So apply, make duplicates. And then the center part and this one H. Good. All these objects we export without using the subsurface modifier. And then let's go to Fusion. We will create a new form. Insert toothbrush. Okay, meters. So you will see actually that this object, when we convert it now, will take a little bit to calculate. There again, Blender or Modo would just zip, make it subdivision surface smooth, but T-Spline has a little bit of work to do. But and again, this is actually perfectly round. But now I would like to cap actually all this tops, and I noticed that if we now go to the Crease command, Fusion can get very, very slow. So what I will do first is I will select these objects, go to Modify, Performance, Display Mode, and then set this to boxy look, which actually will make things a lot faster because it doesn't have to speed everything up. Before we forget, let's delete this one, and then we can go to Crease. And for example, let's rotate the view a little bit. You see already this is quite stop motion. Well, I was already in that select mode, so I can draw a selection over those top faces, and that should crease it. Yeah, and then I do the same also for the bottom. You see, I only select all the faces on the bottom and all the faces or edges on the top. Shoot, this is not what I wanted to happen. You see these sides got selected, so cancel this. And let's do this one more time, but in 2 passes. There. Let's say OK. And let's rotate our view to there. One more time, just the bottom part. Okay, good. And then if we leave finish form, I think we should end up with the cylinders. Because even while you see everything here as boxes, it's a T-spline object. We just set the display mode to box, but once we leave that sculpt mode, we are back to perfectly round cylinders. And there we are. So we need to bring over that split mesh, which we have on this layer here, there, and export there, and Fusion. Let's import it. Meters, okay. Oh, yeah, okay. I could have used actually the base feature, because this is actually a linear geometry, but now I can easily crease the few edges I have here in the T-spline environment. That's fine. So crease this, there. Yeah, crease, please. There. Not too complicated. Not too much to click, only a few lines. Okay, there. Exit. Now, because we have solids, we can easily split all these solids. Let's see, can I select multiple? Yay, I can select multiple bodies to split at the same time. So maybe all those. Yeah, excluding this one. 32, 34. Okay, splitting tool is now, it's this one. There we have an issue, interestingly. Okay, so hold on, what's happening here? How does this object look like inside my timeline? So this is one body, okay. So you see there it doesn't work the way it should, which is unfortunate. But not a big deal. We can simply say split 1, 2, 3, 4, 5 along this face. Zip. Then one more time we say these 3, 4 along this face. Zip. And you, for example, along this face. And when, for example, we delete these parts, you see here there are now our different bodies, which then we could select and remove. I will pause the video for the moment because this might take a minute to do, and then I will be back. Actually, at the moment I stopped the video, I realized there's a small little shortcut. So this feature, the first one, we need to keep alone because this is at an angle, but this plane is the same on the same level. So what I could simply do is, hey, you, and you. No, not you. And these two split along this and extend. And you see the red surface extends because these yellow faces are all at the same plane. Split. And then one more time, I'm gonna say, no, those actually split among this plane. Okay, perfect. And then, for example, this one we can remove. And let's go into a top view. So now I would have to see where's this object there and there. Oh, there's one that's too long. So let's see, you till you. See, it highlights actually all the parts. So you. Where's the one that's inside and is long? This one, body 9. Oh, these two actually did not get cut. Interesting. There are also some other issues that happened here. You see these things were cut, so let's better be safe than sorry. So let's redo this command. So I will do it now in sets. So you. So really be careful with what you click. And all this cut with this lower face here, there. Okay. Then one more time. This time we select those. There. Okay. So where's that plane? There. Let's remove this one. Yeah, now the cut lines are the way they should be. So body 27. Let's see, at one point do these other parts start to pop in there? Oh, hey, one piece disappeared. Or maybe I just only hit it by accident. Oh, shoot, now we're back at there. Oh, what did I do? Okay, one more time. So those. Also, by the way, so everything I do here, I just show you so you understand the process. But these bristles, that's, for example, something I would actually not bring over into Fusion. Or I would only do this if I really want to print these bristles, but actually these bristles are not really printable, so there's no point to what I do here right now to do in Fusion. However, I just wanted to show you the process, and so you understand kind of like what you have to do. The bristles, for rendering purpose, obviously I would only do in Blender, because Blender there would be perfect for this type of geometry for render mode, because that's nothing we will inject geomold or so. So technically speaking, this what I do here right now is just an exercise to show you some of the steps to make you familiar with it, but I never would bring this into Fusion. I would only do this when I really have to, because there's actually no point behind it. There. Oh, not this one. Sorry, this one. There. Okay, and you notice that here I turned select all off and then just bodies, because now it is very easy to select the different bodies with Shift. There, and then right click, remove. There we are. Those two as well. And there. Okay. Perfect. The last piece to do now is maybe to clean up our design a little bit. You can see that our timeline already got pretty long. So maybe we can see where maybe it might make sense to do some grouping things. So for example, this and this, we can group together, zip, and then for example, say rename results. Okay, let's go in front of it. So what's this and this? Oh, that's actually the lettering. Okay, so we go to there. So that's all. So this is all lettering there. What did we remove? That part. Okay, so you to you. Okay, maybe go to there. Right click, create group. Letter. Okay. And then the rest we can either keep in groups, but for example, these were very long command chains, specifically this one, so it is more efficient to quickly put this all into groups, so your timeline is less dense. And then for visual purpose, this is currently difficult to read. Let's apply some materials. So let's say this should be plastic. Let's go plastic, opaque, glossy white. I set this to body on component, so I can drag this one onto here. And there was something with translucent there. Let's say maybe this there. and there. And in this case also here I have to make sure I apply to these tiny fragments here. Okay, maybe zoom in a little bit more. There. And let's bring this bracket to there. Okay. And you see then the software tries to give you kind of like a preview of how stuff looks like. This translucent material is a little bit tricky to read. How does, for example, this blue plastic look like? Yeah, difficult on the eye, so I will simply go with an opaque material, because essentially this is just for color coding your parts so you understand what part you're actually looking at. There. Good. Maybe some of the bristles, so maybe here can make this white and white and white and white, and maybe some blue or so. And yeah, there now we have recreated everything. So you see, time-wise, this took me roughly, including the video, an hour. So to build this CAD model without the video, probably will take me 25 minutes. So it's not export and then you have everything done in Fusion. There is still a little bit of work to be done. But again, to bring this to an end, I was talking about toolboxes and process. Everything that's very organic, and for example, this bend part is very difficult in something like Alias or in Fusion. So it makes sense actually to do that part in Blender, and also because in generally we deal with a very organic shape, and that type of sculpting I could do in Alias with NURB surfaces, but it would be very, very difficult, and with the way how Blender gives us modifiers and subdivision surface and booleans, we can, as you can see here, create a design very fast in Blender, and then when we bring it over into Fusion, we don't have to rebuild everything. We just convert the geometry type, and then we just recreate just the boolean, trimming and cutting and joining, and that's it. So all the work we created in Blender is not lost. We don't have to redo everything in Fusion. We just simply finish it in Fusion. So that's actually the main reason why, for example, I work with these two programs together in a tandem. Blender is very fast and it gives me more control about generative design. Fusion is slower, but it is more precise, and then gives me all the final design features I need. For example, I forgot actually to round this edge. Now, see, this is something we cannot do in Blender because it cannot round trimmed edges because it's a polygon modeler, but Fusion is a solid surface modeler, and I can perfectly round these edges. And maybe with this project, this also explains a little bit about you have different stages in digital design. You have conceptual ideation, so like you do it by hand when you sketch. We do sketching because it's very fast. It's not very representational or correct, but it's more to play through ideas. Same concept modeling in Blender is more about developing ideas, not about being precise. And then what you see here, this then would be the actual, let's say, fabrication model we could use then to make prototypes or send it to engineering, and then they would take a look at this and then either continue working with it or, for example, use it as a blueprint to create their own design part.